We investigated that the strongest metals, in this case compared aluminum with steel is the strongest, so we can see that it needs more force to break, but it generates a smaller neck. So now we proved, with this practice, we proved that it's true and the theory is correct. So the elongation percentage is smaller for strongest metals like steel.
The difference between the aluminum and the steel that we had was that our aluminum became longer with the same force, and then it had more elongation, and then it had less area in the necking part, and so the diameter was smaller than first, and then it took a lot of time to break because it expanded a lot, so it was harder for it to break, but at the end it actually break. And for steel, the necking was not that much, it didn't expand as much, but it broke with with more force, but without expanding so much in less time.
So here we have the elastic limit, which is the point where our material won't ever go back to its original form because of the strength applied to it, the force applied to it. And then we have the UTS, the ultimate tensile strength, which is the highest point of the graph. And here we have the breaking point, which is the point where our material it's broken. Okay, so here we can see the graphs that we could get with the universal machine. Here we have the steel graph, which has its elastic limit over here, then the ultimate tensile strength, and then the breaking point. As we can see in this other graph, which is the aluminum graph, we have the elastic limit over here, which is way higher than the steel. Then we have the ultimate tensile strength that we can see that is less than the steel. And then we have the breaking point, which we can also see that it's earlier than the steel. So we can conclude that the aluminum is a material that is more ductile and that is more fragile. It can be break more easily, broken more easily.
For example, we have an elevator, and these kind of structures have the life of a lot of people, so they need to go through a lot of tests, and one of the most important is the tensile test. This test is very important, like in the example of the elevator, the cables, we need to know how strong they are and how much weight they can carry, so we can anticipate a lot of accidents and the life of the people will be secure.
The most important thing about this practice is that we learned how to use the universal machine. Apart from this, we could see that the different properties from the aluminum and steel.
In this practice, we learned to use only one machine, the universal machine, and we could see the difference in tension that the different materials could resist, and this is important so we can analyze different materials and see what we can use them for and if they're useful or not.
I think that this practice was very important because in the real life it's very important to test the resistance of the materials, so when they are in use, when you're using them, it doesn't came to accidents and stuff that the companies don't want.
In this practice we work with tensile tests with aluminum and steel, and both are metals. And we can conclude that the harder metal, in this case steel, breaks in a more difficult way, but generates a little neck compared with aluminum. So we can see that materials that are less harder generates a bigger neck, like aluminum.